this part we are going to, this is kind of the easy part, says if V is 2I plus 3J, state whether W is parallel, orthogonal, or neither. Remember, parallel will mean that they have the same slopes. Orthogonal will mean that their slopes are negative reciprocals. Remember, another name for orthogonal is perpendicular. This is just like perpendicular. It's just when it happens to vectors, they call it orthogonal. Or it can be neither parallel nor orthogonal. All right, so to start with, what is the slope of V? Remember, it's rise over run, so its slope is 3 over 2. It's the j over the I, the vertical component over the horizontal component. So this has got a slope of 3/2. That's what we're going to be comparing these to. I will change color patterns, maybe it'll seem less confusing. All right, so my first problem here, it's going to have a slope of 6 over 4, which I think you'll agree with me is 3 over 2. And so we would say that this W is parallel because the slopes are exactly the same, okay? And this next one, the slope would be rise over run, or 4 over negative 6, which would reduce to be negative 2/3. Negative 2/3 is considered the negative reciprocal of 3/2, so we would say that this one was orthogonal. Okay, let's do our last one. This one has a slope of 2 over 3, and 2 over 3 is the reciprocal of 3/2, but it's not the negative reciprocal, so we would just say these are neither parallel nor are they orthogonal, okay? They don't always go in the same row as what I gave them. I guess that wasn't a good example, but you know, I think you get the idea. Next, this is kind of the geometric representation of vectors. They tell you you have a vector V that kind of goes due east like this and is that long. Then you have this vector W that's is a little shorter, but it goes this direction here. They ask me to find V plus W. Remember, our rule is put them tip to tail, start at the start, end at the end. Put them tip to tail, start at the start, end at the end. So first of all, I'm going to draw vector V, because they said vector V first, so I think that's about as long as V. And then I draw vector W, putting it tip to tail. So there's vector W. And the resultant, which is like your answer, is start at the start, end at the end. Where did I start? Right here. Where did I end? Right here. So this is my resultant, V plus W. Okay? There is my resultant. On your test, they're just going to show the resultant as your answer, okay? So you're going to have to think of what direction does that look like it's going in. So the next one is V minus W. So what does negative W look like? Well, if W looks like this, then negative W is parallel to it, but it goes the opposite direction. Same length, same kind of parallel, but this one goes opposite direction, okay? So when I do V minus W, I would say, okay, draw a vector V. Let's say it's about that long. Then minus W looks like that, so I put them tip to tail. So there was V and there was negative W. What is the rule? Put them tip to tail, then start at the start, end at the end, and it looks like that, V minus W. There's your vector. These are called the resultant vectors. And there we go, we love our vectors.